Good morning, welcome back, or good afternoon, or good evening. I don't know when you guys watch these things, or if you watch these things. I think the last one got about 7 views within the week, so I don't even know who I'm doing this for anymore. You guys, those of you that are sticking with me, we're going to talk about derivatives more today, but really we're talking about where functions are increasing and decreasing. So on a function going up on a Tuesday. Just before we get into the examples, just to, kind of do a general like what's happening, what are we doing, sort of thing. Derivatives are all about slopes of tangents. If you were to take slopes of tangents in this, like on this part of the curve right here, they would be negative because they have a negative slope. And then this one is still negative, and then as you get closer and closer to the bottom of that valley, like still negative, but not quite as negative. And then eventually you get some slope right here that has a slope of 0. I mean, you get a tangent that has a slope of 0. So on this side of this point, so like if this point is right here, that means everything over here was always decreasing. It was going downhill. All the tangents would have had negative slopes. Then if we switch colors, over here, these would start to be positive slopes. So you get positive, 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 all the way up until this point right here, where it would switch to 0 again, like a slope of 0 for the tangents. And then afterwards, you would get back to negative, negative, negative. So in between these 2 points is where this made up function I made up would be increasing. And then it would jump back to decreasing again. So, you guys, everything over, here, I'll just do it in color. In this section would all be negative values of the derivatives. And then anything in between here and here would be positive values of derivatives. And then over here, it would switch back to negative again. So what I'm getting at, when derivatives switch from positive to negative, there's sort of this turnaround point. You can't see because I'm using my hands to illustrate with the diagram. So stupid. The turnaround point is like here, where you're like, and then it turns around here in the valley. And then there's another turnaround point up here, where the derivative switches from positive to negative or negative to positive. So let's see. First example. Find the intervals. Oh, where that is increasing? I don't like that example. Let's just jump right to the big one. Okay, find the intervals where that function, let's just say, is increasing. So, first step with this is we need to find the derivative of the function, because that's the slope machine. That'll tell us when it's going up and down and all that good stuff. So f prime of x is equal to, bring the 3 out in front, cancels out with the negative 2/3, and you get negative 2x squared. 2 out in front is a 4, drop it down 1, plus 6. Remember, you don't have to worry about that guy in the end. So that's the slope machine. Now, if we go back to this diagram up here, aren't these spots going to have slopes of 0, like the turnaround points, where they have like a flat horizontal tangent? That diagram's getting so pretty. It's a great palette. So if we set the derivative, the slope machine, equal to 0, that can help us find those turnaround points. Now we need to solve this algebra 2 style. You guys see how this, and this are all divisible by negative 2? Let's divide everything by negative 2. And then the 0 divided by negative 2 would still be 0. And then we would get x squared minus 2x minus 3. Cool. Now I need to find two numbers that multiply to negative 3 and add to negative 2. Those would be what? Negative 3 and positive 1? Set those both equal to 0, and you get x is equal to 3 and negative 1. Now, what did I just find? Those are the spots on the curve where it turns around, where it either hits like a valley or a mountain. So, to figure, like, just looking at them, I don't know whether or not this is a valley or mountain, or whether or not this is a valley or a mountain. So, to be able to figure out what's what, I do this thing called a zone test. The zone test is this. I'm going to put a number line out. And then I know something happens at negative 1, and I know something happens at positive 3, but I don't know what. Now, our derivative, f prime of something equals negative 2 times something squared plus 4 times something plus 6. That derivative is the slope machine. So what is about to happen is we're going to pick any number from this zone right here. Just anything less than negative 1. Keep it simple, probably like negative 2. So if I feed negative 2 into my slope machine, let me see, negative 2 squared is positive 4 times negative 2 is negative 8, minus 8 is negative 16, plus 6 is, I think, negative 10. So f of negative 2 is negative 10. The fact that this is negative, I don't even really care about what the number is, but it's negative, which means that in this zone right here, that the function is decreasing. Because the tangents have negative slopes, it's going downhill in that zone. Then I know that it bottoms out at negative 1. Let's zone test in this zone right here. Now, when you zone test, you just pick any number you want and feed it into the derivative. Between negative 1 and 3, I'm going to go with 0. That's a super sweet number to plug in. So if I get rid of these guys right here, whoops. And I put a 0 into this, f prime of 0, the 0 will cancel out everything except for the 6. So f prime of 0 is equal to 6, which I really don't even care what the number is. It's just the fact that it's positive means that that function has to be increasing in this zone. Then I know it does a mountain at the top of 3. And then you should still check a number from this side just to make sure. Yeah, let's check it. Let's do it. Let's pick a number like, what, 4? Something like that? Sure. So let me erase. So put a 4 in these spots. And then you get, what, 16, negative 32, plus 16 is positive. Wait, hold on. Negative 32 plus 16 is negative 16, plus 6 is negative 10? Believe. Which means, based off the fact that that number is negative, that this is decreasing on this side. Now, if I were to just kind of draw what it might look like, that means that it was going downhill in this zone. And then it turns around here at negative 1. Then it goes uphill, uphill, uphill. And then at 3, it turns around again. So the spots where that is decreasing. No, we're going for increasing, right? Yeah, increasing. The only time that it's increasing is here on this section. And that's when x is between negative 1 and positive 3. So that would be our answer. that f of x, the original equation, is increasing on -1 less than x less than 3. It's just between -1 and 3. Yep. Let me see if it's even necessary for me to do another example of this. No, I think you should be good to go with the 13.4 homework. Hit me up during office hours if you need some help. 5 to 7 by appointment only, and I always am reachable by email. All right, kids. Hope you guys are staying safe, having fun, watching good movies. Okay.